Hi guys, speaking is Tsiniso. Welcome to Academia e-learning. If you are new to the channel, please subscribe, comment, and hit that like button below. Today, we're going to focus on Euclidean geometry, and what you should know after the lesson is how to visualize a radius diagram and solving problems using all theorems that have been covered.
Okay, so in this problem here, we are given O as the center, and we are also told that NM is equals to ML. So this one here is equals to this side here. And we also given the angles. Angle MNO is equals to 26 degrees, which is this angle here. And we also given that NKP is equals to 32 degrees, which is this angle here, right? So okay, fine. So now we are asked to determine the size of angle O2, which is this angle here. So the first thing you're going to do is you're going to look at diagram, and just by analyzing the diagram, I see that this side here is theorem 3, right? So if you check, this angle here is twice that angle there. But to see it properly, we can just shift the triangle and put it up there, and then you write K. So this very same K, I just shifted it upwards, and then this is 1, and then the angle is 32 degrees. So now you can easily see that is actually theorem 3, which says that angle at center is equal to twice its circumference. So that's how you're going to solve this problem. So you're going to say angle O2 is equals to twice angle K1. All right. So the reason would be angle at center is equals to twice at circumference, right? So O2 is equals to 2 into, so what is K1? K1 is given as 32 degrees, and then you multiply by 2, it's going to give you 64 degrees. So this is angle O2. Okay, so now B says that we must determine angle O1. So now we are looking for this angle here. So how do we find that angle here? So considering that this is a straight line, right, and we already have 64 here, so for us to find this angle here, we need to identify this angle here, O3 first, right? So how can you identify O3? We are told that this NM is equals to MN, making this 90 degrees, right? And we already have 26 degrees here, so we can easily find O3, right? So we're gonna be like in triangle O and M, right, which looks more like this, and here it's O, and then here it's 3, the one that we want, and this is 90 degrees, and this is 26 degrees. So this is N, and this is M. So we want O3. So I want to say O3, angle O3 plus M plus angle N is equals to 180 degrees. So reason is the sum of angles of interior triangle, right? So we want O3. So we're gonna plus M is equals to 90 degrees plus 26 degrees is equals to 180 degrees. Therefore, angle O3 is equals to 180 degrees minus 26 degrees minus 90 degrees. So if you punch your calculator, angle O3, you're gonna get 64 degrees. So this angle here it's 64 degrees. So now in our straight line, let me draw it here. We have something like this. So our O3 is 64. There, we just got it. And then our O2 is also 64 degrees. Now we want this O1. So to find this O1, you're going to say angle O1 plus angle O2 plus angle O3 is equals to 180 degrees. So reason is straight line. And we already have angle O2 and O3. So angle O1 plus angle O2, which is equal to 64 degrees, plus O3, which is also equal to 64 degrees, is equals to 180 degrees, right? And therefore, if you subtract and say angle O1 is equals to 180 degrees minus 64 degrees and minus 64 degrees, therefore you can confirm and say angle O1 is equals to 52 degrees. So this is this angle here, which is going to be 52 degrees. So now we are asked to prove that KN bisects OKP. So OKP, so this is P, this is K, and this is O, right? So the angle that they're talking about is this one here. So we want to prove that this line of KN bisects the line. So the most important thing that you need to do is we need to identify this angle here. And this angle here must be equal to this angle here. And then it will tell us that the line of KN bisects PKO, right? So the first thing you're going to do is looking at this triangle here. Let me use a different color. So looking at this triangle here that I'm shading, this one, we need to use it, right? So we're going to use this triangle here and we're going to find this angle here, right? We already have angle O1, which is 52 degrees, and we already have angle O2, which is 64 degrees. So if I'm to draw this triangle, it's gonna look like this. And just to indicate, this is O1 and this is O2. So already here 52 degrees. Let me write it properly. So already here we have 52 degrees, and here we have 64 degrees. What we need to take note is that this triangle here, this side is equal to that side, so meaning that it is a radius. So if this side is equal to that side, then which means the angle here is equal to this angle here. So making this triangle an isosceles triangle. So the first step we're going to do is we're going to find these angles here, which we can name as x and x there. So we're going to have x plus angle O1 plus angle O2 is equals to 180 degrees. And then the reason is angles, or you can say interior angles of a triangle, right? So the sum of those interior. So you're going to have 2x plus angle O1, which is 52 degrees, plus angle O2, which is 64 degrees, is equals to 180 degrees. And then 2x is equals to 180 degrees minus 52 minus 64, which will give you, so therefore x is equals to, if you punch your calculator, you're gonna get 52. Okay, now we're gonna have 180 degrees minus 116 degrees, and therefore we have 2x is equals to 64 degrees. Then you divide by 2 both sides, and therefore x is equal to 32 degrees. So this is the angle here, which is 32 degrees. So if you take notes, this angle here is equals to the angle here. So therefore you can conclude and say Kn bisects angle OKP. Thanks for now.